Welcome to another episode of PPL Pod. We operate under this heavy expectation of instant gratification when we interact with digital spaces.
Oh, absolutely. It's the illusion of a frictionless world, really.
Right, like you have a question, you type it into a search bar,
Yeah.
and the internet is just supposed to deliver this neatly packaged answer.
Yeah, we want information to be readily available, instantly categorized, and, served up without us ever having to see the machinery whirring beneath the surface.
Exactly, it's a binary transaction. You search, you find. But then you step into the world of missing information, and suddenly that seamless digital machine just grinds to an absolute halt.
It really does. It just stops.
Yeah, and today we are looking at a landscape full of these digital ghosts. I want you to imagine searching the world's largest, most comprehensive repository of human knowledge for a specific person.
Okay.
Let's say you were looking for Chloe Bailey. You type in the name, you hit enter, fully expecting a biography, and instead you hit a brick wall.
The dreaded error page.
Yes. The encyclopedia simply stares back at you with this bold text that reads, Wikipedia does not have an article with this exact name.
I mean, it is the absolute definition of a digital void. We are so heavily conditioned to believe the internet knows everything, So a literal page not found screen almost feels like a tear in the fabric of reality.
It does. And that is exactly why today's deep dive is focusing on a very specific, somewhat unusual artifact. We are analyzing the exact text, the literal architecture of the Wikipedia error screen for the search query, Chloe Bailey.
Which is such a fascinating document.
It is. And let me be clear up front, while you might know who Chloe Bailey is in the real world, this story isn't actually about her biography.
Right, we're not doing a profile on her music or her acting.
Exactly. We are using her missing page to explore the architecture of absent information. Why does this matter? Because this seemingly empty page, it actually exposes the hidden mechanics, the rules, and the rigid guidelines of how knowledge is built, organized, or just completely blocked online.
Yeah, because a missing page isn't just a blank piece of paper. It's a highly structured, heavily fortified environment that tells us exactly what the internet values and how it defends the integrity of its own database.
It's kind of like imagine walking into the Library of Congress, right? You walk up to the front desk, you ask the librarian for a book by a specific title, and instead of handing you the book, the librarian slides this massive toolkit across the desk and hands you a manual on how to write the book yourself.
I love that. That analogy captures the user experience perfectly. Because before we even get into the mechanisms of why the page is missing, we really have to look at the environment of this text.
The interface itself.
Yeah, the empty page is incredibly busy. When you land on this error screen, you aren't just given a blank white canvas. You are surrounded by this massive dashboard of navigation menus and accessibility toggles.
The margins of this void are just packed. Like looking at our source text, the sidebar offers main page, contents, current events, random article.
Which is standard, sure.
Right. And then you've got a contribute section offering help, learn to edit, and a community portal. But the detail that really stands out to me is the appearance menu.
Oh, the accessibility toggles. Yes.
Wikipedia provides all these user control toggles to customize your reading experience for a page that has absolutely no text to read.
It's so ironic, right? You can change the text to a small, standard, or large font size. You can adjust the width of the page to standard or wide.
Which is wild.
It is. The system is mechanically attempting to accommodate your visual preferences, completely blind to the fact that it has nothing of substance to show you.
And within that appearance menu, there is a color mode toggle. You can choose automatic, light, or dark mode.
Right.
But right beneath those options, specifically on this error page for Chloe Bailey, there is a rigid permanent note. It literally says, this page is always in light mode.
Yeah, this is where we see the collision between a universal user interface and a legacy system page.
Wait, I have to push back on this. If the wrapper, like the UI itself, is universal, why not just let dark mode wash over the text anyway? Why does the system care if an error page looks a little weird in a dark theme? Why even put the button on the screen if the button is forbidden from working?
That is a great question. It's really because of how Wikipedia's underlying code has evolved over decades.
Okay.
The universal UI, the sidebar, the search bar, the accessibility toggles is a modern wrapper that gets applied to every single page request. It's designed to give the entire site a cohesive feel.
Right. So it looks like the same website no matter where you click.
Exactly. But the content area, which in this case is the specific template generating the page not found screen, is much older. These legacy-era templates were often built using hard-coded HTML tables or specific background color variables.
Oh, so they aren't updated.
Right. They haven't been optimized for modern CSS color inversion. If the system allowed dark mode to wash over it, the text might become entirely invisible against a dark background, rendering the diagnostic tools completely useless.
Wow.
So rather than rewriting the core template immediately, the engineers just hard-coded a disclaimer. They are essentially saying, like, we built this modern steering wheel, but it just doesn't connect to the axle of this specific old car yet.
The scaffolding is just entirely exposed. So you hit the page, you are locked in light mode. And the very first thing you experience is that blunt rejection. Wikipedia does not have an article with this exact name.
It's a hard stop.
It is. But the architecture doesn't leave you there, right?
Oh, yeah.
It immediately transitions from an error state to a diagnostic toolkit.
Yeah, the system pivots. It issues a direct call to action. It says, please search for Chloe Bailey in Wikipedia to check for alternative titles or spellings.
And then it offers 2 immediate suggestions, right?
Yes, it tells you to search existing articles or look for pages within the database that link to this title.
So the database basically fails to give you the answer, so it recruits you to become a private investigator.
Pretty much.
By asking you to search existing articles or look for backlinks, it's revealing how digital knowledge is woven together. I mean, Chloe Bailey might not have a dedicated article in this specific query, but her digital footprint might exist as a hyperlink on an album page or like a mention in a film cast list.
Exactly. It demonstrates that knowledge isn't isolated in single siloed pages. It's a relational web.
It's an ecosystem.
Yes, a living ecosystem. The rejection page isn't a dead end. It's a map showing you where the structural gaps are and inviting you to fill them. And to help you do that, the text outlines 3 distinct, well, they call them other reasons this message may be displayed.
Right, these are the mechanical reasons why the page is absent. Let's look at the 3 suspects.
Okay, the first reason the text offers is a database delay.
It states, if a page was recently created here, it may not be visible yet because of the delay in updating the database. Wait a few minutes or try the purge function.
The famous purge function.
I really need to understand this. What exactly is a purge function? Are we clearing out the entire internet's memory bank just to find one article about one person?
Not the entire internet, no, but you are directly interacting with Wikipedia's server architecture.
Okay.
When a website gets the kind of astronomical traffic that Wikipedia does, it cannot physically generate a fresh page from the database every single time a user clicks a link.
I guess the servers would melt.
They absolutely would melt. So they use a content delivery network or a CDN. The system takes a snapshot, like a cached version of a page, and serves that static image to the next million people who ask for it.
Oh, I see. So it's essentially handing out photocopies to save time.
Precisely. It's highly efficient, but it creates a time lag. If a volunteer editor just hit publish on a brand new, fully written biography for Chloe Bailey 5 seconds ago, the CDN might still be handing out the photocopy from 10 minutes ago.
Which is the empty error page.
Exactly.
And the purge function.
The purge function is a manual override. When you click that, you are sending a command through the UI directly to the servers, telling them to throw away the photocopy of that specific URL and go pull the absolute newest live data from the master database.
Wow.
Yeah, you are forcing the system into the present moment.
Okay, that makes complete sense, and it leads logically to the next issue. Suspect number 2. If you hit purge and the page is still empty, the system suggests you look at your own typing. The text explicitly warns titles on Wikipedia are case-sensitive, except for the first character.
Yeah, this is where we run into the rigid, literal nature of legacy database indexing.
I really struggle to wrap my head around this part. I mean, I can go to a modern search engine, completely smash my keyboard, misspell every word, use no capital letters, and the algorithm still knows exactly what I'm looking for.
Yeah, it corrects you immediately.
Right. So why is a repository of human knowledge so archaic that it breaks if a single letter is the wrong case?
Well, because modern search engines use semantic search algorithms. They are designed to interpret human intent. They look at your messy input, compare it to billions of other messy inputs, and guess what you mean. But Wikipedia's internal title search, historically, relies on exact string matching.
Exact string matching.
Yeah. To a computer processing raw data, an uppercase B and a lowercase b are not the same letter. They are entirely different sequences of binary code.
Wait, so if I type Chloe Bailey with a lowercase b, The database doesn't see a typo. It sees a fundamentally different request.
It sees a completely different entity.
Yeah.
But the fascinating architectural quirk here is that caveat in the text, except for the first character.
Right.
The system is programmed to forgive you if you don't capitalize the very first C in Clo, but it demands absolute perfection for every subsequent word.
Why the exception for just the first letter? That seems so arbitrary.
It's actually a historical artifact of how the underlying Wiki software was built.
Yeah.
URLs and page titles were designed to seamlessly link within sentences.
Oh, like if I'm writing a paragraph.
Exactly. If you are writing a paragraph and want to link to the page for apples, you might write the word apples in the middle of a sentence with a lowercase a. The system was designed to automatically capitalize that first letter in the background so the link wouldn't break.
That's clever.
It is, but it only does it for the first letter of the entire string. Anything after that, like the B in Bailey, is on you to get right.
And because the system knows humans are terrible at exact string matching, the error text suggests you check alternative capitalizations and consider adding a redirect here to the correct title.
Yes, it asks you to fix it.
It's asking you to build the plumbing. If you find her page under a different capitalization, it wants you to come back to this empty void and wire it up to transport future users to the correct destination.
It relies entirely on user-generated infrastructure, which, brings us to the third mechanism, which is arguably the most complex.
The deletion log.
The deletion log. The text literally says, if the page has been deleted, check the deletion log and see why was the page I created deleted.
This shifts the narrative entirely for me. It tells us that this empty space might not be an accident, and it might not be a typo. It might be the result of a very deliberate administrative execution.
A man-made void.
Yeah. The page could have existed, someone could have spent hours writing it, and a moderator came along and actively wiped it from the public-facing site.
The fact that the platform has to link to a dedicated essay titled, "Why Was the Page I Created Deleted?" tells you everything you need to know about how frequently this happens.
An entire essay.
An essay. It highlights the massive ongoing tension at the heart of this project, which is the conflict between open inclusion and strict quality control.
And the gatekeeping mechanics, they're actually spelled out right in the source material. Under the very first bullet point, the system tells you exactly what it takes to stop being a passive reader and start being an architect.
Yeah, it lists the requirements.
It says you need to log in or create an account and be auto-confirmed to create new articles. Auto-confirmed. It just sounds incredibly bureaucratic.
It is a digital bureaucracy, but a necessary one. If we look at how open source platforms survive on the internet, auto-confirmed is a brilliant behavioral algorithm.
How so?
Well, you can't just create an account, log in, and immediately start publishing new pages.
But why not? If the goal is to crowdsource human knowledge, shouldn't the doors be wide open?
If the doors are completely open without any friction, the database gets instantly overwhelmed by botnets, spam campaigns, and vandalism.
Oh, right. Bad actors.
Exactly. The concept of being auto-confirmed is a way of measuring trust over time. While our specific text doesn't list the exact mathematical threshold, auto-confirm status generally requires a user account to exist for a certain number of days and to have made a certain number of minor, non-destructive edits to existing pages.
So you have to prove you are a constructive member of society before they hand you the keys to the bulldozer.
That's exactly it. You earn trust through micro-contributions. But the system does recognize that this friction can discourage well-meaning newcomers, so it offers a compromise.
The article wizard.
Yes. The text says, alternatively, you can use the article wizard to submit a draft for review or request a new article.
So what is the article wizard, really?
It's essentially a quarantine zone.
A quarantine zone.
Yeah, like if you aren't auto-confirmed, you can still write the biography for Chloe Bailey, but it doesn't go live. It goes into a massive queue where veteran, trusted editors review the citations, they check the formatting, and they decide if the subject meets the community's strict definitions of notability before it gets published.
It is just fascinating how much human labor is required to maintain the illusion of a seamless digital encyclopedia.
It's staggering.
But my absolute favorite part of this entire error screen is what happens at the very top of the page. Before it even gets into the server lags or the deletion logs, it tries to redirect you to a completely different universe.
Oh, the sister projects.
Yes. It says, look for Chloe Bailey on one of Wikipedia's sister projects.
This reveals the true scale of the Foundation's architectural ambitions. It really does.
I am going to list the options the text provides, because the juxtaposition of searching for a modern person and being offered these specific databases is just surreal.
Let's hear them.
Okay, it suggests you check Wiktionary, Wikibooks, Wikiquote, Wikisource, Wikiversity, Commons, Wikivoyage, Wikidata, and Wikispecies.
It is a sprawling ecosystem.
It's like looking for a person and being handed an atlas, a textbook, a travel guide, and a directory of biological species.
Exactly. But they aren't just different categories. They are fundamentally different architectures designed to hold different shapes of data.
Break that down for me. Why isn't this all just one giant website? Why does a quote need a different architecture than a biography?
Because unstructured text and structured data operate differently.
Yeah, how so?
Well, the main encyclopedia is built for prose, right? Long paragraphs of unstructured text explaining a subject's life or a historical event. But let's look at Wikidata, which is one of the suggestions.
Right.
Wikidata is a relational database. It doesn't want paragraphs. It wants hard data points. Date of birth, coordinates, population numbers. It's designed so that machines and other software can query it.
So Wikipedia is meant for humans to read, and Wikidata is meant for computers to read.
Essentially, yes. And then you look at Wiktionary. That database is architected to handle etymology, pronunciation guides, and translations across hundreds of languages.
That makes sense.
Or Wikisource, which is designed to host raw primary source documents like transcriptions of historical texts. Each of these projects requires a unique back-end structure to categorize and display its specific type of information efficiently.
But the search query itself, the machine processing the error screen, is completely blind to that context.
Totally blind. The system doesn't know what Cloe-Bailey is. It just knows that the specific string of characters, CHLOEBAILE, did not return a match in the prose encyclopedia.
It has no idea.
None. It has no idea if you are searching for a 19th century poem that belongs in Wikisource, or a newly discovered breed of moth that belongs in Wikispecies, or, a famous monument in France that belongs in Wikivoyage.
So it just hands you the atlas, the dictionary, the biological index, and the travel guide, and asks you to figure it out.
It's a phenomenal defense mechanism. The computer fails, so it overwhelms you with options.
Which brings us to the real nuance, the unresolved mystery of our deep dive today. We've explored the legacy code of the dark mode button. We've looked at server caching and the purge function. We talked about the bureaucracy of the deletion log. But we really have to embrace the unknown here.
We do.
Based purely on the text of this error page, we have absolutely no idea why Cloe-Bailey is missing.
We must acknowledge the hard limits of our source material. We have the diagnostic map, but we do not have the final destination. We cannot confirm anything about her career, her life, or her level of fame based on this text.
But looking at the name itself, there's a massive technical variable staring right at us. The laut.
Ah, yes.
The two little dots over the O in Cloe.
The special character. This is huge.
Given everything we just discussed about how rigidly literal this legacy database is, with case sensitivity and exact string matching, could the umlaut be the culprit? Is it possible that an incredibly detailed article does exist for Cloe-Bailey without the umlaut, and this specific search query just tripped over a special character?
It is highly probable. In database architecture, special characters introduce a whole layer of complexity regarding character encoding.
Really? Why?
Well, systems historically used basic ASCII encoding, which only understands standard English letters. Modern systems use UTF-8, which can understand an O with an umlaut.
Okay.
But to a literal database, Chloe with a standard O and Clo with an O are as different as apple and orange. They possess completely different underlying byte values.
So if a user types the umlaut and the creator of the page didn't, the system declares a total mismatch and throws up the void.
Exactly. It points right back to that prompt on the screen. Check for alternative titles or spellings. The system is practically begging the user to strip away the special character and try again.
But we also have to hold the competing interpretation that the page was actively destroyed.
True.
Maybe a fan tried to create it, but they weren't auto-confirmed. Maybe they bypassed the article wizard, the formatting was wrong, and a veteran editor wiped it from the server.
Or perhaps it's simply that database lag we talked about. Maybe someone published the page 2 minutes ago, and the CDN is still serving us the old empty snapshot.
Right.
The beauty and the frustration of analyzing this specific source material is that all of these realities are equally possible simultaneously. We are looking at a system in a state of suspension.
We really are. We started today with the tension of a digital ghost, a search query that led nowhere. The actual biography for Chloe Bailey remains entirely unwritten in our source material. We don't know who she is, what she's done, or why she triggered this specific error screen.
But by exploring the architecture of that void, we learned an immense amount about how information is governed on the internet.
We really did. We saw the scaffolding. We learned how CDNs and purge functions manage massive traffic, how databases interpret string data and special characters, and how digital communities use friction and autoconfirmation to defend themselves against chaos.
We learned that what looks like a dead end is actually a highly active construction zone. It's begging you to put on a hard hat and build the infrastructure yourself.
So I want to leave you with a thought to mull over. We've spent this entire time talking about how humans interact with these missing pages, the rules we have to follow, and the logs we have to check.
Right.
But as we move further into an era dominated by artificial intelligence, we have to ask a new question. These massive language models are scraping the internet to learn about human history. They train on what is there.
Which is terrifying if you think about it.
Right. What happens to our collective history when these AI models are trained exclusively on platforms where information is routinely and automatically deleted because a digital bureaucracy decided it lacked notability? If the internet's most comprehensive encyclopedia leaves a void, does the AI assume the subject never existed at all? Thanks for listening to PPL Pod. Keep tuning in for more stories worth knowing.